कंडीशन हमारे पास आ गई कि हाइट इज इक्वल्स टू रेडियस ऑफ द बेस. नाउ फाइंड द सेकेंड डेरिवेटिव. 3 into 2 6 pi r by 2 minus 3 pi r. When height is equals to radius, then also it has same value. Negative, it means volume is maximum. Therefore, volume is maximum when height is equals to radius of the base. Here, the next one, show that the height of cylinder of maximum volume that can be inscribed in a sphere of radius A is equals to this. We have to prove that height of a cylinder inscribed in sphere. Sphere का radius हमें given है A. Radius of the sphere is A. Write down. Let R be the radius of the base and H be the height of cylinder. Let this as radius. Height is denoted by this x in x. Now in triangle OAM, A square is equals to R square plus x square. R is AM radius. A square minus x square. So we get R as square root of A square minus x square. Now we have to prove volume maximum. Volume of cylinder is pi R square H. Radius is A square minus x square. Height of the cylinder is, this is OM is x, so full height will be 2 times OM, that is 2x. So we get 2 pi A square x minus 2 pi x cube. Clear? Now differentiate it with respect to x. 2 pi A square, 2 into 3 is 6 pi x square. First derivative equal to 0. So we get 2 pi A square is equals to 6 pi x square. Pi will get cancelled. A square is equals to 3x square. X is A upon root 3. X is A upon root 3. Now find the second derivative. D square V upon dx square. 6 into 2, 12 pi x. When x is equals to A upon root 3. A upon root 3. Then also it is less than 0. Now volume is maximum. Now we have to prove that height is equals to 2 times this. हमारे पास height क्या है? 2 into x. तो put the value. H is 2, x is A upon root 3. तो first condition हमारे पास proof हो गई कि when height is equals to this times radius of the sphere, volume is maximum when H is equals to 2A upon root 3. Next one, show that the semi-vertical angle of cone, let this is a cone VAB. Show that the semi-vertical angle of cone, semi-vertical angle, this is semi-vertical angle of cone of maximum volume and given slant height is, we have to prove that this semi-vertical angle is equals to this. Now let alpha be the semi-vertical angle of cone. We have to find these sides in triangle AOV. Sin alpha is equals to P upon H. Cos alpha is equals to B upon H. Base upon hypotenuse, perpendicular upon hypotenuse. Angle की जो सामने की side होती है, that is always perpendicular. So perpendicular AO. This is slant height of a cone L upon hypotenuse is L. So from here we get AO as L sin alpha. So AO side is L sin alpha. Base, जिस line पे angle बना होता है, that is base. So VO, hypotenuse is L. So VO is L cos alpha. Clear? Now what is the volume of cone? Volume of cone is 1 by 3 pi r square h. यही होता है हमारे पास. रेडियस क्या है? OA. R square, height is OV. यही है हमारे पास. Now put the value of OA and OV. We have the value of these. 1 by 3 pi r square L square sin square alpha. OV is L cos alpha. So we get pi by 3 L cube sin square alpha cos alpha. Clear? Now we have to find the first derivative. Alpha angle is variable here. So pi by 3 L cube, apply U into V rule here. First derivative of cos plus second cos as it is. Derivative of sin square is 2 sin. Derivative of sin is cos of alpha. So we get pi L cube by 3 minus sin cube alpha plus 2 sin alpha cos square alpha. Now in the next step, take sin alpha common. Pi L cube by 3 sin alpha. So 2 cos square alpha minus sin square alpha. Now put first derivative equal to 0. So what we get? Sin alpha 2 cos square alpha minus sin square alpha is equals to 0. So note up to here first. So in the next step we get sin alpha is 0 or 2 cos square alpha minus sin square alpha is equals to 0 is equals to sin square. Sin square upon cos square. Sin upon cos is tan, so tan square alpha, or we get tan alpha as root 2, or alpha is tan inverse root 2. Now we have to prove that the volume is maximum. Find the second derivative. Pi L cube by 3 minus derivative of sin cube 3 sin square alpha, derivative of sin is cos, plus 2 first U into V rule, first derivative of second plus second as it is, derivative of sin is cos. So we get pi L cube by 3 minus 3 sin square alpha cos alpha minus 4 sin square alpha cos alpha plus 4 cos cube alpha. Cos cube alpha is here because we have taken 2 common. Now in the next step, d square v upon d alpha square pi L cube by 3. Take cos cube alpha common. So this is 7. 2 minus 7 sin square alpha cos alpha. Cos cube alpha common. So we have to divide this term by cos cube alpha. So pi L cube by 3 cos cube alpha 2 minus 7 sin square upon cos square, that is tan square. Pi L cube by 3 cos cube alpha 2 minus 7 tan square alpha. Now we have this value. We have to find the value when tan alpha is equals to root 2. When tan alpha is root 2, let this as angle alpha. Tan is perpendicular upon base. Perpendicular upon base. Because we want the value of cos alpha there. So hypotenuse square is perpendicular square plus base square. So we get hypotenuse as root 3. Now what is cos alpha? Base upon hypotenuse. This is base and this is hypotenuse. So cos alpha is 1 upon root 3. Clear कि यहाँ पे हमारे पास cos alpha की वैल्यू कैसे आई? हमारे पास क्या था? Tan alpha root 2 था. Tan alpha is perpendicular upon base. So base is 1. And cos alpha is base upon hypotenuse. Hypotenuse is equals to square root of perpendicular square plus base square. So now we have to find d square v upon d alpha square when tan alpha is equals to root 2. Then we have cos alpha 1 upon root 3 cube. 2 minus 7 tan square alpha is 2. 7 into 2 14. So pi L cube 9 root 3 14 minus 2 minus 12. So that is less than 0. Therefore, volume is maximum when tan alpha is equals to root 2. That is, alpha is tan inverse root 2. Semi-vertical angle is equals to tan inverse root 2. Note it down. Now the next one, show that the semi-vertical angle of a right circular cone of given surface area and maximum volume is this. Let this is a cone VAB with radius R, height H and slant height L. This is the semi-vertical angle alpha. Now what is the formula for surface area of the cone? Base is in circle, therefore area is pi r square plus pi r L. Find the value of L, S minus pi r square upon pi r. Volume of the cone. What is the volume of the cone? 1 by 3 pi r square h. यही होता है हमारे पास. And what is L? We know L square is equals to r square plus h square. Or h square is L square minus r square. So squaring both sides, because here we have h. If we write the term in square root, so that will be little complicated. So to avoid complications, we are putting it as this, so that we can put the value of square h square by multiplying, squaring both sides. Pi square r4 h square. Now put the value of h square. L square minus r square. Clear? So what we get? Now put the value of L here. V square 1 by 9 pi square r4. L square is s minus pi r square square. Pi square r square minus r square. Pi square r4 upon 9. Take the LCM here. Open the bracket. A minus b whole square. A square plus b square minus 2ab minus pi square r4. This term will get cancelled. Pi square and r square will get cancelled. So r square by 9, s square minus 2s pi r square. Let v square as z. So we get z as 1 upon 9 s square r square minus 2s pi r4. Take s common. So s r square minus 2 pi r4. Note up to here first. Surface area has constant value, therefore S is constant. Now differentiate it with respect to R. S by 9, 2SR minus 4 into 2, 8 pi R cube. Now put first derivative equal to 0, we get 2SR S is equals to 4 pi R square. Clear? Now put the value of R square is S upon 4 pi. Now find the second derivative. What we get? Derivative of 2SR minus 8 into 3, 24 pi R square. Now put the value of R square. D square z upon dr square s by 9 2s minus 24 pi r square is s upon 4 pi. So s by 9 2s minus 6x minus 4 s square by 9 negative, therefore it is less than 0. Z is denoted by the volume, therefore the volume is maximum. Therefore volume is maximum when S is equals to 4 pi R square. Now here put the value of S, pi RL plus pi R square. So 4 minus 1 R will get cancelled, pi will get cancelled. So L is 3R. L is equals to 3R. Now sin alpha. Sin alpha is perpendicular upon hypotenuse. Perpendicular is R and L. Put the value of L here. So 1 by 3, or we can say that alpha is sin inverse 1 by 3. Note it down. Now the next one. Show that the volume of the largest cone that can be inscribed in sphere of radius capital R. Sphere के अंदर cone is inscribed. And radius of the sphere is denoted by capital R. Volume of the largest cone that can be inscribed in sphere of radius R. We have to prove that volume of cone is equals to 8 by 27 volume of sphere. this is what we want to prove. Write down. Let height of the cone is 2x. Its radius is denoted by small r. This is the semi-vertical angle alpha. This as O. Now in triangle A, O and C, r square is equals to x square plus r square. So r square is this. So radius is equals to r square minus x square. Now volume of the cone. We have to prove volume of cone is equals to this. So we take first volume of cone. 1 by 3 pi r square h. Put the value of r square. R square is this. Height is 2x. Height is, this is the radius, then this is also the radius of the sphere. So our height will be r plus x here. Clear? Because O is the set. Now the cone is inscribed in sphere. अगर sphere का ये radius है center से, तो ये भी तो radius होगा, और ये height जो cone की है, हमने इसको x मान लिया. So height will be r plus x here. Clear? Now open the brackets. 1 by 3 pi r square